The camera arrives on a juvenile great white. An oarfish drifts into view. The shark circles it once, twice, 3 times, and leaves it alive. Across 68.5 hours of footage, researchers recorded 85 encounters with animals classified as potential prey, yet the cameras captured not one successful predation. That sounds like a failed shark film. It is actually the discovery. Cameras and motion sensors on young white sharks off Australia's east coast found no ocean of constant attack. They found long glides, sandy highways, improbable companions, and flashes of speed so rare they occupied just 0.112% of the footage. This is not the great white we are usually shown, it is the great white between the headlines. Published July 8, 2026 in Frontiers in Marine Science, the study followed sharks along the New South Wales coast, between Evans Head and Port Macquarie. Researchers attached packages to the first dorsal fins of 13 juvenile white sharks measuring 1.74 to 2.83 meters. Each combined a 2K camera, depth sensor, and 3-axis accelerometer sampling movement 20 times per second. Radio and satellite transmitters helped recover the units after they detached 4 to 10 days later. For 12 deployments, daylight recording began 24 hours after release, a conservative delay intended to exclude capture recovery. One camera instead switched on only when forward acceleration crossed a set threshold. 2 trained observers then coded the footage second by second. Low light and poor angles removed some material. 11 sharks supplied 68.5 usable hours. Only 7 had enough continuous footage, at least 5 hours, to support time and habitat comparisons. For those 7 sharks, the dominant landscape was not open water, it was the bottom. They spent 50.1% of coded time swimming along the seafloor and 34.5% near the surface. Just 9.2% was spent in the pelagic zone, away from both, and 96.3% of that midwater time was transition, moving up or down. The motion sensors added another layer. During descents, sharks glided without the side-to-side head movement used to identify active swimming 58% of the time. The reported average depth was 51 meters. The deepest point was 115 meters, where 2 sharks remained for 45 and 51 minutes. In this sample, the shark's day was not a continuous high-speed patrol. It had a vertical rhythm, surface, descent, seabed, ascent. A body known for explosive power repeatedly descended without the obvious head swing of active swimming. When the seabed was visible, one habitat dominated. Sand accounted for 89% of coded bottom habitat, compared with 9% reef and 2.1% kelp. That does not prove juvenile white sharks prefer sand. The region itself has little topographic variation, with mostly sandy sediment and patchy reef. The authors say fine-scale habitat maps and precise shark locations would be needed to separate choice from availability. But the footage offers clues. Cameras passed ray feeding pits and cephalopod ink signs of feeding and recent animal activity on an empty-looking bottom. When reef appeared, sharks often moved around its edges rather than directly over it. Researchers suggest low-complexity ground may offer benthic prey such as rays, easier movement, or both. It changes the familiar hunting picture. Here, the seafloor was not scenery beneath the predator. It was the main road and the starting line for most sudden accelerations. The researchers defined a burst as a substantial increase in side-to-side head movement, signaling faster tail beats and speed. Only 6 of 11 sharks showed one. In 68.5 hours, there were 20 bursts lasting 5 to 54 seconds. Together, they totaled 298 seconds, 0.12% of observation time. None ended in a successful capture. 16 began while a shark was swimming along the seafloor. 10 continued horizontally along the bottom, 7 climbed, and 3 descended. In only 3 burst events could researchers identify the animals ahead: a marlin, a dolphin, and, in one event, a moray eel and an octopus. These bursts should not all be called attacks. The paper describes many as investigatory or unsuccessful, and a camera cannot tell us intent. Across 10 sharks, the team logged 85 encounters with potential prey. Only 3 were associated with bursts. Most of the time, shark and animal showed little obvious response to each other. The hidden story may be less about what a great white can chase than what it chooses not to. Camera-bearing sharks rose roughly 70 to 80 meters from the seafloor during encounters with another white shark and a hammerhead. Neither side showed a clear response, and the tagged sharks promptly returned to the bottom. The cue that triggered those climbs remains unknown. A stingaree sped away when a white shark came within 3 to 4 meters. The oarfish was circled 3 times, but not bitten. Scattered fish bones held one shark's attention for 14 minutes. Then there were the escorts. A single guiding fish, usually a yellowtail scad or pilot fish, appeared with 7 sharks for 17 hours. On 2 deployments, it was present for 83% and 91% of the recorded period. Groups of baitfish were recorded around 8 sharks for 13.5 hours. Altogether, interactions with small fish appeared in 44% of the footage. The authors cautiously call this likely commensal. Fish may gain protection or feeding opportunities while the shark is largely unaffected. Likely matters. 4 times, baitfish scraped against a shark's head, perhaps using its rough skin to remove their own ectoparasites. 4 other times, a shark abruptly turned and accelerated toward baitfish behind it. Even an escort can sit one decision away from becoming prey. So, what did the shark body cam prove? Not that every great white lives this way. 13 juveniles were tagged, 11 produced usable footage, and only 7 supported the habitat time analysis. They came from one nearshore region and measured 1.74 to 2.83 meters. 12 cameras were scheduled to record continuously in daylight. The 13th was acceleration triggered, and low light footage was not coded. Murky scenes and bad angles were excluded. Bursts were too rare for comparisons by sex, size, or context. The acceleration triggered camera was used only for prey and behavioral response analysis, not routine habitat use. No kill on camera does not mean the sharks did not feed. 50% on the bottom is not a universal white shark rule. An ascent toward another animal does not reveal motive. What the study gives us is narrower and more valuable. A second-by-second record of what these young predators approached, ignored, followed, and left behind. It replaces a highlight reel with a life. For almost all 68.5 recorded hours, the famous burst never came. Instead, there was sand, depth, restraint, and a small fish keeping pace beside a feared silhouette in the sea. The animal we fear for its explosive moments spends almost all its documented time doing something else. And that may be the most astonishing footage of all.